My name is Martin Schichtel, and I beat the often path by combining history and future to resolve a couple of issues in our energy system.
Today's episode is proof that when an idea sounds too good to be true, it doesn't mean that it's not possible. It just means that it's a great business idea, maybe. Well, Martin Schichtel leveraged unique industry insight to build a business that captures the enormous amount of waste that so many different industries blast out without giving it a second thought. He patented energy storing blocks that can store 1.2 megawatt hours of thermal energy at a temperature level of up to 1,300 degrees C. This means that we can store the heat byproducts of tons of heavy industries, which can translate into cost savings, decarbonizing entire industries, and generally making our whole society much more efficient. Now, he had a brilliant idea. He executed on that idea, and he saw near immediate success bringing his brilliance into the world. I love crazy, out-of-the-box solutions like this, and I know you will too. So here's Martin Schichtel. I'm Ross Palmer, and this is Beat the Often Path. Well, welcome to the show, Martin. You've done some very fascinating stuff. You're clearly a person who's been building the future for a very long time, decades even, and you have begun in material science, and you are really pioneering a bunch of things that I find very fascinating in sustainable energy. So first of all, how the heck did you get here? How did you end up on this crazy path?
This really is a quite long story. Actually, it was not a typical, let's say, start-up thing to say, hey, that's the idea, I will do it. That's why I said I combined history with the future, right? So I was working, especially the last decade, in selling ceramic products, special ceramic coatings to steel, glass, ceramics industry. And those were smart coatings helping to increase energy efficiency of furnaces, ovens, and things like that. Means, on the other hand, I've seen a lot of energy wasting, right? A lot of flue gases from the chimney into the atmosphere without being used. Actually, I never thought about that before. And then in 2008, roughly, I saw a TV report about heat storage made of concrete. I found it pretty interesting, right? Cheap material, you can cast in each shape, available worldwide. But the confusing thing was they named themselves a high temperature heat storage, but could only store 500 degrees C. So I was calling just the inventors, which was a German research institute and a construction company, actually. I said, why is there a limit in temperature? Why can't you store at 1,000 degrees? So why not at 2,000 degrees C? We discussed, actually, we met also in person for 2 days, discussed about this topic. And it turned out that concrete is the problem itself, because this cannot bear that much temperature. And from that time, it was just, for me, curiosity and a scientific approach to figure out how to improve concrete. I didn't even at that point think about building a company, solving world's problem, but just, it was a challenge, right? And that's exactly what I did. I took this challenge, started thinking about typical scientific approach, what's the problem, literature research, things like that, and came up with a new storage material. And this was the point, roughly 4 years later, to think about what could such a heat storage do in the future, how it should look like to reduce things like heat in flue gases. How can we do it in green heat, right? Converting electricity to heat. And that's where the idea of our company of Kraftblock started racing in my head, and building the company started.
That's amazing. And you started that in 2014, right? So that's relatively new, I guess.
Yeah,
Okay.
It's relatively new. It depends how you define startup. Right here in Germany, you define
I guess it's
startup,
old.
Maximum. Oh, well.
Startup years, yeah. I guess it's almost a decade old. That's not so bad. Okay, so yeah, when I think of things like smart coatings, these are the types of words that ignorant people such as myself, who aren't very technical, you hear these things and you think, okay, clearly these are important things. There's a lot of money to be made. What you just described seems very important because this is heavy industry stuff, which most people don't know anything about. So I guess before we get into the Kraftblock solution specifically, how did you find yourself interested in materials to begin with at the start of your career? Why did you go into the material space, and why did you pursue that path? What motivated you on those ideas?
I assume, actually, it was my parents when I have been 6 or 7 years old, right? They were always interested in nature. So none of them studied something, right? So both were totally normal parents, but always interested in nature. We're explaining a lot about biology, plants, mineralogy, things like that. So I think they brought me to this pathway into direction of thinking about materials, natural science in general. And starting from high school, I was fascinated from chemistry. And actually, I think with 14, 15, it was pretty clear that we'll study chemistry because I was thinking about how does this work? How could nature work by using chemistry? So again, just curiosity, how does it work at the end? And that's where I was coming to this topic. Well, chemistry first, material science a little bit later, but the same cosmos.
Okay, so but your parents inspired you. You figured you had a passion for this and a talent for it, and then you decided, okay, this is the field that I want to go into. And from that, you saw a lot of waste, and that waste led you to form this concept.
Yeah, I think if you're in the field of chemistry and working in different positions and different industries, you see a lot of things that could go better in the future, right? We are thinking about, I've been in the plastics industry also. A lot of plastic waste, plastic pollution nowadays here, thinking about biodegradable plastics at the moment, things like that. Nobody thought about this 20 years ago, right? And I think we need people who try to come out of the box with new ideas, with new approaches, new challenges to get the troubles of the old world solved. And that's a little bit what I am or what I try to do.
Yeah, well, it seems like you're doing it. Sustainability, was that something that you've always been interested in? Or is that something that you, like you said, you just discovered this is a wasteful thing and I think I can fix it? Have you cared about some of those global issues like climate change and climate tech before?
If you would have asked this question, let's say 10, 12 years ago, I was typical petrol head, loving big cars, wonderful fast. I mean, in Germany, we do not have any speed limits. That's also a reason to love fast cars, of course. But
wait, I gotta interrupt you there. I have to interrupt you there because when the first time I saw Kraftblock and I was thinking of Kraftwerk, which I'm a big techno fan. I was thinking of we're fahren off the Autobahn.
Oh yeah,
that was the first thought that went to my head. So is that the inspiration for Kraftblock? Do you say I want to be like Kraftwerk but with my own company?
Might have been unconscious, but no. It was really when we were looking for a name. We screened with the team, with our investors, with friends and family. Roughly 80 names, and Kraftblock was the one turned out to be a pretty good one because Kraft, it's in German also for power, right? So Kraft is power. Kraft is also a little bit like handmade, if you like, think in craft beers or things like that. And block, I mean, that's the format of our storage. It's just the kind of block that we offer.
Like a Lego block,
So yeah, it's a perfect mixture out of our world. We also took, of course, a look at Google, Bing, Yahoo on the search engines. And when we found the name Kraftblock, it was amazing because there were two hits in Kraftblock. One is the German, which means your weight training, if you do exercise, if you sports in the gym, which is also a Kraftblock in Germany.
Okay.
And the other one was, you still can find it today, a cheddar cheese from Heinz.
I was going to say, cheese. That's what we as American know. Yeah, because we have a Kraft cheese company. Yeah, it's like American cheese. I thought that would be more obscure, but I love that you found that. Like, give me a Kraftblock. I'm hungry. That's funny.
Something like that.
It's too funny. Okay, so that's where the name comes from. All right. So you used to be a petrol head, as you said. Big cars. You loved gasoline. You loved that feeling. And then suddenly which is a fascinating story because not everybody comes from that angle. And I think it's inspiring to me to think, okay, somebody can come from that and maybe switch gears and start thinking about the future. So, all right, so 10, 12 years ago, completely different path. What made you kind of change and start going this way?
Actually, it was, as I tried to explain a little bit, the transition of what I have seen in my career path and thinking about new approaches, how to solve those problems, and thinking about why people never thought about solving this problem, right? Everybody is knowing since 10 years, 15 years, don't know, maybe even 80 years, that there's a lot of heat and flue gases, steel, glass, ceramics industry, cement industry, even chemical industry. And I mean, on one hand, it's wasted carbon dioxide or wasted emission because you used oil, gas, or coke to produce this heat. On the other hand is, of course, wasted money because you bought the gas and you just waste 50% of the gas for flue gases. So it doesn't make any sense, even from economics. That was a little bit the mind quarrel I fought by myself to figure out what is the right approach, what is the right path, why should we do it today?
All right, so concrete wasn't the answer. It wasn't hot enough. And I think based on doing this show from other people, we know that concrete itself, the manufacturer,
Oh
has
yeah.
its share of problems, right? It's not very
Yes.
sustainable as it's been traditionally done. And yet your product seems to be 85%
Hmm.
sustainable materials. You mentioned that you don't use rare earth materials.
No.
So you've patented, if I'm not mistaken, this technology, which goes up to
Yeah.
1300 degrees, which is much
Hmm.
hotter. So, what types of materials, what was the breakthrough that you found there that allowed you to store so much more heat than the previous solutions?
Um, it was a mixture out of sustainability thinking and a new approach to say, okay, well, nobody really took or cared about designing thermal energy storage materials, right? So people thought about concrete. We talked about this before. People are thinking about natural-based material like basalt, sand, volcanic rock, so existing materials already. Um, I think only in steel industry, there's a heat storage comparable to ours for 50, 60 years. Not very efficient, but it's existing, which is a tailor-made material for these purposes. But none other materials have been tailor-made, especially in sensible storage materials before. So we try to mix sustainability with a new approach to design a thermal storage material. Um, and we are using actually steel slag, so waste material from the steel production itself. We are using things like refractory materials that are put on disposal sites because every 10, 15 years, for example, each furnace in steel industry or in glass industry have to be reconstructed more or less. So they are replacing the old refractories against new ones. Also a lot of waste. And these materials are pretty brilliant because they already have seen high temperatures, so they won't change anymore. They are stable. We usually say thermal and mechanically dead because there's nothing, no movement, no phase change anymore. And on the other hand, and these are the 10 to 15%, a special type of binder. So from the old world circular economy, we take the heat capacity and we use the heat conductivity for this binder. And that's why we can tailor our storage material to different purposes, what else it is. And based on that, we even can create a new materials class, even for further development of material in terms of capacity, use cases, and things like that.
Wow, okay, so you think this is just the beginning. You think you've still got room
Yes,
to go. Wow,
definitely.
okay.
I
All
cannot
right,
solve the
so
old problems with the old
yeah,
technologies, right? Because they created
right.
those problems. So I have to think about new ways.
So let's talk about the significance. I mean, obviously on your website, you mentioned a number of industries. Again, things that
Mm.
average people such as myself, we don't think about. It's something like the paper industry produces 5% of,
Yeah.
was it carbon or heat? And so there's lots of different industries that you mentioned. Also, we know, I think anybody who
Mhm.
studies sustainable energy knows that it's not just generating the energy that's the issue, but it's storing and capturing that
Yes.
energy that's the
Yeah.
issue. And you mentioned in your home of Germany that windmills, when they reach excess capacity, they just shut them off. They don't generate energy anymore, which is, of course,
Yep.
wasted energy, right? So, talk to me about how just simply storing high heat or energy in the form of heat, what are the implications of that? And why is that such a
Mm.
significant thing for so many different industries?
Yeah. So first of all, Ross, I also had to learn a lot about heat and processes where they are used, right? I never thought about pulp and paper too, because never have been in this industry. But it's the same for food industry. It's the same for textile industry and a couple of more industries. They do have a lot of process heat demand. The complexity of heat is that heat is not the heat, right? You can have heat like steam. You can have it as hot air, thermal oil, frying fat. What else? These are all is heat, but all different types of applications. That's why it's so complicated to get a grasp on heat itself. If you take a couple of rough figures and say, okay, let's have a look on the energy demand of a nation, then average worldwide, and that's pretty fascinating, 50% of this energy demand is heat demand. Only
Hmm.
30% is electricity and roughly 20% is fuels. So you can see very simply, heat is the big elephant in the room. And 80, 85, 90% of this heat is still generated using fossil fuels. Gas, of course, natural gas, oil and coal. And the next step is quite easy. If you can decarbonize this part of the heat, really make a huge step in our race against climate change because we avoid 25, 28% of the emissions, or we could avoid if we decarbonize heat. And that's the way we want to go. Um, Our approach is, and you already mentioned it, we can use, of course, renewables. Renewables, usually PV, wind. It's not continuous energy production, energy generation. It's fluctuating, right? You have peak loads. You have hours without any wind, without any sun. So it's not really fully calculable. So you need a storage that buffers the energy in between. For example, if you have run PV, sun only shines during the day, right? You have to bridge the night hours. So you store excess from the PV to use it for the night hours. The simplest example why to use the storage. And you also mentioned it in Germany. Well, Germany is pretty special. We do have what is called Erneuerbare Energiengesetz, which is pretty brilliant for operators of PV farms or wind farms, because I think they get paid for 90% of the energy they do not deliver when they have to shut down. So that they get their money anyway. And that's a little bit crazy, because last year in Germany, it was 1.6, what was a billion euro that was paid to those operators to shut down their plants.
Doesn't
make
any
sense.
Good. No. Okay. So we've got the heat captured, and I've seen your graph, and it all stores in the blocks, right? And you mentioned that they last 40 years, or you didn't mention, but it's on the website.
It's on the website,
which is incredible. They can charge many cycles, 1 cycle per day. So once we've captured and stored this high heat, how do we then get it out of there, and how do we then push it to all of those applications that it can be useful in?
I think this is a quite special approach that we have taken. We have said, let's split the energy or the storage system into 3 different parts. One is the storage itself. The other one is the charging device. And the third one is the discharging device, which means we created a storage platform, because the storage for us is always the same. But the interfaces, the couplings can be different. It could be power to heat systems used in renewable electricity, which is converted to heat and stored. Could be waste heat recycling, so steel, glass, ceramics, where waste heat already is existing, could be taken into the storage and stored. And the same for the discharging, right? So the big question is, what type of heat does the customer need, or what type of energy? Does he need steam? Does he need thermal oil, hot air, cold? Even electricity could be possible, because at the end, it's nothing else but producing steam that operates a steam turbine. So we can tailor it really perfectly for the customer demand at the end. And that's what we're usually doing, right? So standardized storage, different coupling size to satisfy different demands. The easiest way for us, usually if we talk about high grade heat, so not below 400 degrees C, if you talk about higher than 400, usually the heat transport is done by a type of gas. Could be air, could be directly from the flue gas. So you take a hot air into the storage device itself, our pellets absorb the heat, and then cold air exits. If we need the energy again, we just pump cold air through the storage, which absorbs again the heat and takes it to the application, for example, steam generation. That's as simple as it is.
That's amazing. So how long can you actually store the heat in these blocks?
A thermal storage, a high temperature energy storage, very important to mention this, is designed to store for a few hours till a few days. We can do the exercise on maximum 2 weeks. And in 2 weeks, we say, okay, that's a little bit the break point where it's not economic anymore. So maximum 2 weeks.
You've got partners like Mitsubishi and other people. So obviously you're catching on in your home country and elsewhere. So what can some of these companies like Mitsubishi, what can they expect? How do they benefit from working with you? And what has changed in their process from working with you?
First of all, those companies have to learn a lot, because just to give you a very, very illustrative example, when we talked to customers 2 or 3 years ago about high temperature energy storage, the customer always say, hey, that's pretty good, 120 degrees C hot water storage. No, we are thinking about 800, 1000, 1300 degrees.
Right.
How should this work?
Right.
So the market education was very, very low. Only some specialists knew what is a high temperature energy storage itself. So we had to educate the market. We had to educate our partners. We had to educate the customers. And this worked out pretty well. So now they are understanding what is this type of storage, what can it do, what are the use cases. And then, depends on how the partnership works. It could be a kind of sales channel for us. It could be support in engineering and so-called EPC services, which take care about the whole project. So we just could deliver the storage itself and really focus on our core developments. This is pretty different. So most of the work we do with our partners today is really educating them, taking them to the point where they can use the storage best.
Well, that's what we're helping with right now. We're educating because this is all new. It's so exciting. So if you had your way and there was an ideal future and this went as far as you can possibly imagine, what would the implications of wide adoption of this be in, say, the next 5 or 10 years?
Well, it would be pretty cool if storages, whether it's thermal storage like ours or also battery storage, it doesn't matter, would be really a essential pillar of the energy system in the future. Because I'm convinced without the thermal storage, we cannot fully shift to renewables in the future, or we have to invent other technologies. So if a storage would be in Germany say 0815, so if it's a well-known standard would be used in 5 years or in 10 years, that would be amazing.
That makes sense. So from your position, now that you've been in this and you know more about the industry than the average person, what do you think the biggest opportunity is just in general? Do you think this is it? Do you see other things? What do you see basically that people such as myself don't see who aren't immersed in it?
Well, first of all, I see a small battle in new technologies. I mean, it's very helpful because it shows that there is a big market for those opportunities in the future, right? So mostly we compete against hydrogen. In Europe, Germany especially, but Europe also, it's a big driver in the market. A lot of people are crying for hydrogen because it's green, you can burn it, you can do anything else. But at the end, the efficiency to generate it is pretty low, and it doesn't make sense in all the use cases politicians especially dream about. We see battery energy storage, which is also good. You already mentioned it, rare earth and things like that, but also high cost for battery storages. So also in terms of thermal process heat, it doesn't make any sense to install a battery storage. The option is a thermal storage, and that's why there are thermal storages in the market. The point is that especially, let's say, even the engineers, even the site operators, which should have a full view on their system, a full view on their processes, should have a glimpse on how thermal storage systems could help, how they could support their systems. I just can remember when we visited one of the biggest steel mills in the world. We have been there for 2 weeks and went really from position to position, from side point to side point, from location to location, to do a mapping. Where do we have waste heat? How complicated is the engineering? I mean, those companies should know this by themselves, right? It should not be an external party with a new idea coming up and doing a screening and mapping to increase the energy efficiency of those plants.
Right.
And that's what I think it's pretty crazy. But probably it is because people do it in their daily work. They do not think about it. They just operate it, right? They do not think how to improve it, how to increase energy efficiency, how to let's say, resolve a couple of even mechanic problems in their processes. And that is what I think that's crazy. But if they understand, well, storage can do this, you can integrate in this process without having interference with their quality of their products and things like that, then they can take the next step. And that's why I think what you mentioned, Ross, you are not in this topic. You cannot see a lot of things. And there are people who are professional in this area, and they still can't see the issues.
So they don't see it. Yeah.
That's why I think it's pretty good if you have people with an external view, right, who have not been in the process before, who have not been in the industry before, to have a new approach to solve those problems.
Because it seems to me that throughout our society, from companies to individuals, we think in terms of an input-output model, right? Even in my own personal life, I get a plastic package, I open the plastic package, I throw the plastic away. And all of us pretty much think about is just the cost of that. How much did it cost me to get that plastic package? And if that cost is right, I'm happy. I don't really think about what happens to the plastic afterwards. And I think a lot of companies operate in the very same way. They say if it's cheap enough to get an input from here, output goes there. Very few people are thinking about, okay, but does that output have value, or are we inefficient as long as the cost makes sense? And I think because we've just been operating in this shareholder mentality where we're just trying to maximize profits, there hasn't been any incentive in collecting some of that waste that we're going through. And now we're at a point as a species where we say, hey, yes, bringing in more resources is a valuable thing, but we also need to kind of make better use of the resources that we have. And then, like you mentioned, the circular economy is something that I'm endlessly fascinated with, about how can we reuse and be more efficient in what we do have. We know that that's a big deal, right?
Yeah, it is, definitely. I mean, it is always the problem, let's say in economics itself or in industries itself, right? Nobody wants to wave the green sustainability flag if they lose money introducing new
Right,
process.
because you can't sell that to your shareholders.
No, you can't sell it. So at the end, it's you and me probably who will decide about the green future or not, right? So if I take a look to the new generation, right? So we do have things like Fridays for Future and other movements in the world. So the new, let's say the new generation of youth obviously seems to have a pretty different approach than we had before. And I think if the end customer is aware, and the youth will be the end customer of the future, or is it already today, is aware about that topic, that, hey, look, I don't want to have any snack anymore, which is not sustainable, which releases carbon dioxide. I do not want to drink a soft drink, which is not sustainable. That's the pressure the industry needs.
Yeah. Completely agree. So now, having gone from a decade of being a petrol head to this, where you clearly see a lot and you're very intelligent about the future, and I think your viewpoints have shifted in a broader sense, do you feel that you're fundamentally optimistic about the future of humanity? Are you pessimistic? Are you not sure? Will we shoot ourselves in the foot, to use an expression, or will we survive? Will we pull through? How do you feel day to day about that?
That's a pretty good question. I like it. And there are a lot of answers I do have to this question. So first of all, I'm an optimist. I'm fully optimist. So I really believe I can jump from a skyscraper and pass each floor and says, well, it turned out to be good. And maybe I hit the floor. Maybe I learned to fly. I don't know yet. So I really fully positive person. Our Earth will survive. I'm convinced. I mean, nature always was able to adjust to each of the conditions which happened in the past, even if with the impact of what was the meteor hitting the Earth and
the giant meteor,
wiping away all the dinosaurs, nature survived. Whether mankind survived, not sure about this. If we can adapt, or if we try to evolve ourselves to the next stage, and even if it's to say just think more sustainable, then we will have a good chance.
And you believe that we will. You believe that we will overcome these hurdles and be more sustainable and be that utopian future, or at least a better version of our future.
Actually, I'm quite optimistic. Maybe not in the next 10 or 20 years, but as I said, I'm really fully backing on our youth to say, hey, guys, you made a lot of mistakes in the past. We have to correct it somehow. We'll find our way in the future. We need your help. We need your support. I think in this combination, we can do it.
So what do you think an ideal future would be like on the longer term? I mean, obviously, we know that there are tremendous disparities country to country on the planet right now. There are places, 350 almost unlivable cities right now with pollution. There have been studies that have recently come out that says air pollution is worse than tobacco. So we know, and if you've traveled the world at all, there's a lot of places that have a very, very different view of what society should be, or, not saying through any fault of their own, but as a result of the systems that we're in. The planet is almost unlivable currently for a large number of people based on these systems. So in your mind, what would that ideal scenario be? What would it look like? What would life be like if everything worked out?
Well, ideally, world would be more international, right? We are talking about refugees also trying to leave their countries because of climate, because of wars. And especially in Europe, we face a couple of problems by even trying to help those people to build, let's say, to build a new future somewhere, and that's pretty complicated, I think, and that's probably the biggest obstacle nobody wants to leave his way of living they have today. Nobody wants to say, okay, I spend a little bit more money for this. I do not drive my car anymore. I take public services or things like this. So everybody wants just to stay where they are, and maybe even spend more gas, oil, just to get more comfort in the comfort zone.
Right.
On the other way, I also believe that there is a big chance in the upcoming nations, right? If you talk about India, if you talk about Africa, those are nations which do not never experienced fully what, let's say, the oil and gas industry could bring us with benefits, whether it's cars or just heating systems or furnaces or ovens. So those regions really have a strong chance directly to jump into the renewable business already today.
Just skip a step.
Just skip a step. That's what they also, for example, in Africa did with the mobile phones, right? They never had phones on the line like we have experienced in the past. They directly skipped one step and went to the mobile world. Probably the GSM is much better than in Germany, but anyway, that's a different story. So I think there is, but it's all about internationalization, right? Everybody has to accept the others. Everybody should support others. And I say, stay away from my country, keep out there, just stay where you are. That's the biggest issue I see for the future.
I completely agree. We're all on this one tiny dot and we have to act like it. I think that's absolutely right. And we have to make those kinds of hard choices. And because even I watched this documentary about, Singapore, and Singapore is this paragon that everybody takes public transportation. They made it outrageously expensive to own cars, which is positive because they have a huge population and there just aren't that many people on the roads. That's good. But then you see a wealthy millionaire driving a car and it's some kind of extreme status symbol. And you think, okay, well, then that's still like that. We're not all the way there yet because now you just want to be a multimillionaire to be able to get a car. And then, so there are steps, but obviously, we have a lot of work to do on the individual level of what do we think is an ideal life and what are we willing to do to make that ideal life? What are we willing to give up? Is it plastic forks? Is it plastic packaging? What conveniences are we willing to change? But I think, what you're doing is awesome. I'm very, very glad that we got the opportunity to talk. You clearly have your head on correctly, as we say. And so I guess the last question I have is about the building of the business itself. I'm sure you took a huge risk at the time when you actually started. You've taken on funding. How has that journey gone? Was it always something that you felt would be successful? Were there extreme struggles in the beginning stages? Were there moments where you thought, I don't know what I'm doing, I've made a big mistake?
No. No, actually, a simple...
straight up, blast off and go.
A simple no.
Okay.
I was and I still am convinced that is one of the perfect solutions, especially for industries. Might not be for private homes. And that's why we also selected industries as the first customer, because I believe, there's a lot of money, so industries can pay for the CapEx at the end. Private homes might be very difficult to do it. And B, if we are able to decarbonize just one industrial site, we probably would have to decarbonize heat for 8,000 or 10,000 private homes or one family homes at the same time. So it's easier to do this step in industry. And as I said, 25% of the carbon dioxide release in heat is coming from industry. So just a big portion. And that's, again, the combination out of my history or my past in the industry and the future that we can take now to see where is energy waste or wasted energy, how to resolve this problem, and take it to a better way, to a transition way, to a pathway for the future. I mean, what we can do with our system is also to go, for example, in the steel industry, say, okay, guys, you do have a waste heat stream, let's recover it. Put it back to your process. You don't need that much gas the next time we operate your process. In the next stage, and that's what I really like, and why I think there's also a big future also in 40, 50, 60 years for storages, we can convert this waste heat recycling system to a renewable system, right? Because I just install a power to heat system, convert electricity to heat, and operate it for the same process. So we can help them in a quite long time to do their transition from old ones to the very new, to the future industries. And that was my conviction from the very beginning when I founded the company. Funding, completely different story. Funding in Germany, Europe especially, is quite, how to say, not slow, but low at the end. So if I just compare to what is happening in the US or even in Asia, funding for clean tech companies is extremely amazing. Here in Europe, people are quite restrictive. Well, you do not only have to have an idea to get some funding, you should have your prototype in space, your pilot for the next stage, first commercial contracts for the next stage, this and that, for the full sales pipeline. So it's a bit different, but it's working out quite well.
So just a much more conservative approach, a much more conservative approach to investing, it sounds like, which makes it much more difficult if you're just starting out. That's awesome. So did a lot of people then, investors and first contracts, did they have the same kind of impression that I had, where once they saw what you were talking about, was it immediately light bulb going off and, oh, I see? Because that's the way I felt when I stumbled across your website. I thought, oh, this is just obvious, brilliant.
Actually, it's exactly the same way. If people, as soon as people understand what we are doing and what the implications are, it's this mind sparkling event and say, yeah, okay, that's cool. Let's do this.
Well, that's so fascinating. And I think we as regular folk, there's nothing that's more inspiring than thinking that there are solutions to problems that you didn't even know existed. And that's where I personally find my joy. That's the joy of doing this show, is to find entirely new categories where people such as yourself are doing amazing things, because you think, oh, I didn't even know this was a problem, and there's somebody working on a solution to a problem that I didn't even know it existed, right? Nothing is more fun than that. And that's what I seek out with all of these episodes. So I'm glad I found you. I can't thank you enough for taking the time. I think it's absolutely brilliant, and I look forward to the widespread adoption of your technology. May you continue to improve and increase your materials science, and may you get to that next level in the next 10 years. So I guess before we wrap things up here, do you have a bit of parting advice for anybody who maybe wants to make a difference or a positive change in the climate, either via entrepreneurship or other means? What would you suggest to somebody who thinks, I want to get involved? How can they contribute to a better planet for all of us?
I think the simplest one is stay curious. If you don't have an answer to a question, ask until you understood why a problem is a problem, or could be a problem is a problem, because that's the beginning of all new developments, of all new technologies, of all new movements. So curiosity is really a very, very big and wonderful thing.
Couldn't have said it better myself. Well, thanks again, Martin. And with that, the official podcast is over. Thank you, sir.
Thanks for being there, Ross.